Energy. Look at these two bows. Which one of the two bows has the capacity to do work? Please recall, capacity to do work means capacity to exert force and to cause displacement. Obviously, the first bow is having the capacity to do work. It can exert force on the arrow and cause it to displace, while the second bow cannot. The first bow can do work because of the stretched position of this string. Look at these two flower pots. Which one of the two flower pots has the capacity to do work? Obviously, the first one. It is kept at some height. When it falls down from this height, it can exert force on any object and cause it to displace. This flower pot could do work because of its position. Let us use these two examples to understand what is energy. Whenever work is to be done, energy is required. Greater the amount of energy that a body possesses, larger is the amount of work it can do. So, we conclude energy is the capacity to do work. Whenever work is done, energy of body changes. Object that does work loses energy. In this figure, the person is doing work on the trolley. So the person loses energy. Object on which work is done gains energy. In this drawing, the trolley gains energy. It is during this transformation of energy that force arises and does the work. Since it is during energy transformations that force arises and does work, therefore the unit of energy is the same as that of work, that is joule. So how much is 1 joule of energy? 1 joule of energy is the energy required to do 1 joule of work. There are several forms of energy that we are aware of, like sound energy, light energy, wind energy, solar energy, heat energy, chemical energy, nuclear energy, electrical energy, and so on. We shall focus on mechanical energy. It is the energy by the virtue of which a body can do mechanical work directly. By doing mechanical work, we mean that it can apply force on a body, causing it to displace. Such type of energy is mechanical energy. Light, sound, heat, etc. are not the examples of mechanical energy, as they cannot apply force on an object to cause it to displace. It is mechanical energy which enables an object to apply a force on another object, causing it to be displaced. Thus, a body that possesses mechanical energy is able to do work. Or vice versa, to do work, a body should possess mechanical energy. There are basically two types of mechanical energy. First is the potential energy and second is the kinetic energy. Potential energy is the stored energy. The stored energy could be due to, first, the atoms and atomic bonds, in which case it would be called as chemical potential energy. The stored energy could be due to the change in shape of the body, in which case it would be called as elastic potential energy. Or the stored energy could be due to position of the object, in which case it would be called as the gravitational potential energy. Kinetic energy is the energy possessed by a body due to its motion. Let us see the first type of potential energy, that is the chemical potential energy. As already discussed, it is stored in atoms and the bonds between the atoms. This energy is released by various chemical reactions. For example, petrol. It has got stored potential energy in the form of chemical potential energy. When petrol undergoes reaction inside the engine of a vehicle, this energy gets converted into kinetic energy. This kinetic energy is given to the wheels and the vehicle moves. The food we eat possesses chemical potential energy. We convert this chemical potential energy into mechanical energy, and thus we are able to apply force and cause displacement. The second type of potential energy is the elastic potential energy. It is stored in objects due to the deformation in their shape. By deformation in shape, we mean stretching or compressing. For example, a stretched rubber or a compressed spring. Let us see the example of compressed spring. In a static condition, a spring cannot do any work. But if it is compressed or stretched, it gains elastic potential energy, and in these conditions it is able to do work. That is, it is able to exert force and cause displacement. The third type of potential energy is the gravitational potential energy. It is the energy stored in an object due to its vertical position or height. Let us see the gravitational potential energy with the help of an example of a book. The book is kept on the ground and thus it has got no potential energy as its height is 0. It is now lifted and kept at the top of a bookshelf. It has gained height. Thus, it has gained gravitational potential energy, which is the energy due to the height of an object. Where did this gravitational potential energy come into the book? When a person lifted the book, the stored chemical potential energy from food converted to the gravitational potential energy and got stored inside the book. Mathematically, potential energy is the product of mass, acceleration due to gravity, and the height. So we see that more the mass, more would be the potential energy. Also, more the height of the object, more would be its potential energy. If we double the height, potential energy would also double. We have already seen that kinetic energy is the energy possessed by the body due to its motion. Mathematically, kinetic energy is equal to half into mass into the square of its velocity. Thus, more the mass, more is the kinetic energy. Also, more the velocity, more would be its kinetic energy. Here, if velocity becomes double, kinetic energy would become 4 times. Let us try to identify the energies in a stretched bow. A person possesses stored chemical potential energy derived from food. He does work on the bow, that is, he applies force on the string, causing it to displace or stretch. Shape of the bow changes. Thus, chemical potential energy has now converted to elastic potential energy and is stored inside the bow string. So initially, the position of the bow was like this. When work was done on it, its position became like this. The string is now in the stretched form. Thus, it has gained elastic potential energy. When the person releases the arrow or the string, the stretched string applies force on the arrow, causing it to displace. The elastic potential energy of the string is now given to the arrow as kinetic energy, and hence it travels a long distance. Let us identify the energies in a toy car. A child possesses chemical potential energy derived from food. He does work in winding the coil of the car. His energy is now stored in the coil in the form of elastic potential energy. When the coil unwinds, elastic potential energy gets converted into kinetic energy, which is imparted to the wheels, causing them to rotate. As a result, the car moves forward. Let us identify the energies in a pendulum. An oscillating pendulum has basically two positions. The position at the center is called the mean position or the equilibrium position. At the two corners, the position is called the extreme position. At the first extreme position on the left, the velocity of the bob of the pendulum is 0. We know kinetic energy is half mass into square of velocity. Since velocity is 0, kinetic energy is 0. But at this position, the height of the bob from the initial position is maximum. Since potential energy is the product of mass, acceleration due to gravity and height, potential energy at this point is maximum. When the pendulum starts swinging towards the equilibrium position, its velocity starts increasing. As a result, the kinetic energy also starts to increase, but the height starts to decrease, and hence potential energy also starts decreasing. At the mean position, the velocity is maximum, and consequently the kinetic energy at this point is maximum. But the height at this position being 0, the potential energy at this point is 0. Now, when the bob of the pendulum starts swinging towards the right hand side corner or the second extreme position, the kinetic energy goes on decreasing because the velocity has started to decrease. At the extreme position, the velocity ultimately becomes 0 and hence kinetic energy becomes 0. But during this process, the potential energy is increasing because the height is increasing. At the extreme position, the height is maximum and hence the potential energy is maximum. So we see the change in energy is from 0 kinetic energy at the extreme positions to maximum kinetic energy at equilibrium position, and maximum potential energy at extreme positions to 0 potential energy at mean position. Let us see some more examples of energy. In a car, stored chemical potential energy of petrol is converted into kinetic energy. In a windmill, wind energy is converted into kinetic energy. This kinetic energy is further converted into electrical energy. Water stored in a dam has potential energy. This potential energy is the gravitational potential energy. While falling down, it converts into kinetic energy. This kinetic energy runs turbines and gets converted into electrical energy that we use. Some important things to remember. Mechanical energy is the sum of both kinetic energy and potential energy. Kinetic energy of a body cannot be negative, though it can be zero if the body is at rest. Similarly, the potential energy of a body cannot be negative. It can also be zero if its relative height is zero. Look at this animation. Force is applied on an object and displacement takes place in the same direction. We know when the direction of force and the direction of displacement is same, then the work done is positive. So when the work done on a body is positive, its velocity increases and so does its kinetic energy. We know one more example of work where the direction of force and direction of displacement are mutually opposite. In such a case, the work done we know is negative. When the work done on a body is negative, its velocity decreases and so does its kinetic energy. Potential energy of an object depends upon the height through which it is raised. In this case, the book is raised from ground to the top of a table. It does not matter what path is followed. We shall now raise the book through a different path, but to the same height. As already told, the path is not important. The displacement of the book in both the cases is same. The height through which the book is raised in both the cases is same, and hence the potential energy gained by the book in both the cases is same. Let us recall. Energy is the capacity to do work. More the energy a body possesses, more is the work that it can do. Object that does work loses energy, while the object on which work is done gains energy. During energy transformation, force arises and does the work. Unit of work and energy is same, that is Joule. There are several forms of energy that we have studied. A body is said to possess mechanical energy if it can do mechanical work directly. Mechanical energy is of two types, potential energy and kinetic energy. Potential energy is the stored energy in a body which could be due to first atoms and atomic bonds, in which case we call it chemical potential energy. It could be due to shape when we call it elastic potential energy, or it could be due to its position when we call it gravitational potential energy. Kinetic energy is the energy due to the motion of the body. Mathematically, potential energy is equal to mgh. Kinetic energy is equal to half mv square. Mechanical energy is kinetic energy plus potential energy. When the work done on a body is positive, its velocity increases, and so does its kinetic energy. When the work done on a body is negative, its velocity decreases, and so does its kinetic energy.